Hey everyone. So what we're going to do is we're going to look at some other ways of plotting. This is section 2 in the book. We're going to start with stem and leaf plots. And stem and leaf plots are used a lot in observational statistics. It's a way of recording your data and getting a visualization of it at the same time. And what it does is it provides a way of writing down numbers and getting a kind of a histogram. It gets rid of the class width and it takes the number itself. So what I'm going to do here is I'm going to look at a particular set of data that's in the textbook where it's the 50 cell phone users. They have the number of text messages they've sent within a billing period. And what we notice if we look at the numbers here is we have 3 and 2-digit numbers. And so what we're going to do is we're going to break apart the digits to record our data, our frequency histogram. So how? Now I have this, you can flip to this in your book. It's in section 2. I have it open on another screen here because there's 50 pieces of data here and I want to be able to go through this. And so what we're going to do is we're going to break each number. So for example, 76. We're going to focus on this part of it, and 149, we'll focus on this part. So we break the ones part out. So looking at this data, I go all the way up to 149. And so what I'm going to need is I'm going to need 0 to 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. And so each piece of data I will record where it is. So for example, the first number is 76. And so I've got one piece of data for 76. The second number is 49. Let me draw a line here to separate this. What I wanted to do there is draw that line. There we go. And so the first piece of data is 76, so I write a 6. The next piece of data is 49, then 102. And so notice I still have the number I originally had. 76 was the original number I had. And I'm starting to build a histogram. Now, by default, the bin widths, or the class width, is 10. Because this is based off of digits, and our digits are to base 10, this gives me a way of doing base 10. So let's say I did 102, then 58, then 88, then 122, then 76 again, then 89, then 67, then 80, then 66, then 80 again, then 78, then 69, then 56, then 76, then 115, then 99, then 72, then 19, then 41, then 86, then 48. And notice how I'm just grabbing, I'm going through the list of data, and I'm grabbing the last digit, and I'm putting it in here, but I still have each piece of data. I haven't lost it like I did with the frequency distributions. And so 48 is still in there, 41 is still in there. I can still reassemble my data. So let's see, 52, 28, 26, 29, 33, 26, 20, 33, 24, 43, 16, 39. And so just again grabbing the last digit and building my 29, 32, 29, 32, 29, 29, 29, 40, 23, 33, 30, 41, 33, 38, 34, 53, 30, and 149. And I now have a plot with all my original data in it. And so if you could imagine, let's say you're counting birds or you're out in a field somewhere, you can make a notebook and record your data in a way that you can look at this, and if I flip this over on its end, I can see a histogram in here. By arranging this distribution just out of the digits, I already get an idea that I have a center of data around here. More stuff is frequent down here. I also have another little hump. And so we can kind of think of there's kind of two middles. And we might ask ourselves why of our data there's two middles here. And I can kind of think of that this is probably two kind of income brackets, or these are people that have unlimited, and these are people that pay per text. And so these are things that we would have to look into deeper. We now have our data, we can see something, and we see these two areas where things tend to come together, and then we can look at our data a little more closely to figure out what that means for us. But a stem and leaf plot generates the histogram inside of it, and I can regenerate each piece of data. Right? This was 33, this was 33, this was 39. And so all my information is still within my chart. And so, again, we're converting numbers into visual space, into geometric space, so that we can have a feeling for where our data is, if it's bunching up. And then we have to interpret, what does that bunching up mean coming across? And so stem and leaf is a popular way of doing it. You can also, if we wanted to spread this out a bit, we could double our digits. We could do 0 to 5, 5 to 10, and we could double. And your textbook does do a doubling to see if we can see anything else in the distributions that come out. And so this would be, class from 0 to 5. This would be 6 to 9. This would be 10 to 15. This would be 16 to 19, right? And we're able to put all of our data into here. And so stem and leaf plots are a nice way of doing it. Now I'm going to switch over to the PowerPoint and show a dot plot, which is related to the stem and leaf plot. And what it does is the same data on a dot plot looks like this. And so you put a dot where each number would come on the number line. And you still get your visualization. Problem with dot plots sometimes is it can smear out data. This second lumping in here is smeared out a little bit more. And we definitely see the heavy distribution over here in the 30s, between the 26 and 35. And then a little spike out here. But there's a dot for each number coming across. And so a dot plot is constructed very similarly to a histogram, except you put a dot down for each number. Right. And what I'm going to do here is we're going to look at a couple more different graphs that we can see. And for one of them, and then we're going to explore these a little more with technology. And so one way we can do is a pie chart. And a pie chart cuts a circle into pieces, like pieces of a pie, I know, so that you can visually see how much some category has of a total whole. And pop back over here and scroll down a bit. Pie charts really do that trick I was saying that is going to be our game here, is we take data and we turn it into geometry so we can visualize it. And what generally happens is there's 360 degrees in a circle, and so for whatever fraction there is, we divide our pie equally. And so when you make pie charts, usually knowing the relative frequency as a percentage is useful, and we build pie charts into percentages. And so what you do is you take, let me use the data in the book here. So let's say the degree people have, and for an associate's degree, a bachelor's degree, a master's degree, or a doctoral degree, we have 1,003 associate's degrees, we have 1,870 bachelor's. This is the number in, I think, 2014, how many degrees were conferred. I think this is in the thousands. And we can convert these into percentages. So one of the things we have to do is we have to add up all of the degrees to get our n. And so if you hear me typing away, I'm on my calculator in the background here. And so there were a total of, again, these are in the thousands. Let's see, 3,805,000 degrees. And then I do my relative frequency. I do my f over n. So doing f over n, okay, so this is my n. So f over n, I'm going to use my calculator. 1003 divided by 3805 is approximately 26%. 1870 divided by 3805 is approximately 49%. 754 divided by 3805 is about 20%. And 178 divided by 3805 is approximately 5%. Now let me see if I add all these up. And it's 71, 76, 90, let's see, 71, 91, 96. I have a rounding error here. Make sure I didn't round anything. Let me redo the 178 divided by, yep, 754, yep, 1870, yep. Let's see, so 26 plus 49 plus 20 plus 5, yeah, that's 100%. And so what we do with a pie chart is we break the pie chart off. So 49 is close to 50%. So I'm going to divide in half. And so this half over here, that'll be my bachelor's degree, right? Because it's close to 49%. And 26% is close to a quarter. So I'll break this into half again. And I'll change colors here. Whoops. And that's my associate's degrees. And then, let's see, 20% is not quite a quarter, so we'll go like that. And that's my master's degrees, and these are my doctoral degrees. And we can now visually compare, well, bachelor's take up a lot. And your book walks you through, what a pie chart does. But notice the trick we're doing here. We're taking the relative frequency and we're turning it into space. Space that we can see or feel if we have these constructed. And then we use that as a visual clue to see how much data we have. And out of a whole, right? We have how much of the whole. And pie charts are really a good, quick way of seeing that data. All right, and the last chart we're going to look at is called a Pareto chart. And a Pareto chart is a way of looking at qualitative data, where we look at the categories and we put the categories in descending order. And so the last chart we're going to see here is a Pareto chart. And so what you do is you have your different categories and you let the frequency be the height. And you start with your highest and you work your way down. So you're ordering this from the greatest amount of things to the less amount of things. It's similar to a histogram, but because we're recognizing that these are qualitative data and that they're numerically not related, we make sure we have the gaps in them. And here's an example of a Pareto chart. And what the data they used is they took the leading cause of death in the U.S. and you want to put them in order. So heart disease was the highest, cancer was the next, then chronic lower respiratory, then accidents, then strokes. And you put this in the chart so that you can see about how much, right? And we notice the jump from cancer and heart disease is much larger because this is visually made towers out of these. All right, that's section 2. Section 2, stem and leaf plots and dot plots take up a big chunk of what we can constructively do, and building these other charts are useful. But notice the nature of the game. Turn data into things that we can visualize, that we can turn it into a geometry so that we can talk about the quantity of stuff in this geometric term. And that's going to be a big thing that we're going to do from here on out. And so that's really all of section 2.